most of them are my old friends and I have been knowing for long period. I don't think I needed an introduction here because I am fairly known to the people who are come to listen to this lecture. It's really my privilege to be invited to celebrate the eventful and productive life of Shailopati Gupta, whom I had an opportunity of knowing even before I had graduated from BE College. Am I audible at the end of the... Okay. You see, I remember a December day of 1956. BE College was agog for the centenary arrangements in December. We were all eagerly waiting that the Prime Minister of India, Jawaharlal Nehru, will come for the centenary event. The college had been freshly painted and decorated, hoping that the BE College will attract the attention of the Prime Minister and get some reasonable acceptance in the country. On 25th of December, if I am not wrong, there was heavy shower, very unexpected, but heavy shower, and it was decided that the exhibition will be held in what is now known as Lord's, but that Lord's was a different Lord's in those days because it had just been filled up with Ganges silt and brought by lorries and therefore was in a soft condition. The rains made the entire ground absolutely sloggy and full with water because its level was also lower than the roads. The exhibition was a very massive affair and specially done because we came to know that Pandit Nehru is very fond of attending technical college exhibitions and he wants to know about all the projects which are being presented. On the 26th, we were preparing a model, a large model under Professor Chiranjeev Sarkar, I think also Shailodhar classmate. And it was a very sad spectacle because the pandal which had been done has been completely washed off and everything was wet, everything was covered. You see, we tried our best to restore our model, but nothing could be done because it was knee-deep mud over there and we just could not move. The Prime Minister was supposed to come on the 28th, if I am not wrong. And the face of the principal, Professor A.C. Ray, he was himself a little dark person. And with this happening, one could not look at his face. Everybody was grim, everybody was sad, and we just did not know what to do. So we came back quite late at night on 26th, completely given up that the exhibition would not be there. On 27th morning, we came to know that after we have returned, some BE College students from PWD had taken the initiative to rebuild and to dry up this ground, which appeared to be an impossible task. But I do not know how they organized huge number of lorries which brought sand and sawdust. There are a lot of timber manufacturing units near BE College, so the entire quantity of sawdust was brought and was dumped, and by 27th afternoon, the place looked much more reasonable and dried, and tarpaulins were placed on that, and it looked reasonable. So we naturally went back with enthusiasm, worked whole night. In our term it was Rat Futo Kora. So we worked through the whole night, and on 28th it came to a shape where the Prime Minister could be welcomed. Now this team of engineers, Shoilada was there, Orida was there, I do not know, I do not remember others, but I remember that Shoilada was all the time smiling. He did not show any despair, and that was my first introduction. I have never really worked with him directly, either under him or with him, excepting that there were a number of times when he was executive engineer, I had gone to him to get my designs approved on behalf of BBJ for this ESI. When he was in ESI, he was also looking after the BC Rai Polyclinic or this children hospital, and the pipe foundations used to be approved by him. So that gave me a deep understanding of his very, very active life, eventful and productive. He would never waste time on unproductive matters. So I have great respect to Shoilada as a professional, and I am deeply indebted to Aditi and Gautam for giving me this opportunity of celebrating his eventful life. What better, next one. What better project to talk about than the Vidyasagar Setu? Because it's a project which was very dear to his heart. He had spent a lot of active time on this project, and he had contributed, even after he has formally retired and not been attached, he still used to keep touch and keep note of whatever was happening till the day the project was complete. Well, next slide please. Today we look at this bridge. It's a work of art. It looks like a stringed instrument ready for people to come from heaven and play music. And every time we look at this structure, anybody who had been involved with this bridge will always feel very happy and very, very passionate about it. Now, coming to a little history, you see, I find many of the people here, there is a mixture of young and old, and I am sure those who are my generation or after, they will love to remember how this project came up and what was the development, why it took so much time, and how did this develop. You see, Calcutta is a gift of River Hooghly. Kolkata would never have come if River Hooghly was not there. You see, River Hooghly had been the preferred trading route for entire Europe. The ladies of Europe used to long for Bengal textile, and almost all European countries had sent their vessels to Bengal for not only taking sarees but textile and many other objects. It was a passage navigable for those ships of those days which required less draft. It was navigable right up to Triveni, and most of the European countries, they sent their ships up to Triveni, and that area used to be the trading point. All the suppliers would come there, and that is why, when this Jubilee Bridge was constructed, it had been kept with a lot of clearance so that ships could move up to there. But the British were always different. They decided to make the port or make their trading hub. It was not a port, it was just a trading hub. What it? Yeah. Oh. You know, they made their trading hub in Calcutta, near Kolkata. They had the foresight that ships are becoming heavier and the draft would not be there. So they decided to locate, though the area was marshy, it was full of mosquitoes and pestilence. It was a difficult area to live and one of the most challenging places to make a new settlement. It had always been a query amongst people why Britishers chose the eastern side of the river instead of the western side, which was much more approachable, easily communicable, and higher altitude, and drainage was never a problem. They chose the eastern side, many suspect, because they are scared of the Portuguese. The Marathas used to come all the way. You know, we had all heard the verse, Portuguese Deshe. You know, and Britishers also made the Maratha ditch on the north to protect the city from Portuguese. So it could be that, or it could be some other thinking, but the founders decided to make this the trading hub. Initially it was ships used to come and exchange the exchange their trading materials. Now, Calcutta incidentally had become the first port in the country. It was in 1870 that the port was formed in Calcutta. You know, the port trust, the law was passed for setting up a port at Calcutta. The two railways, East Bengal Railway and Bengal Nagpur Railway, they made their terminal at Howrah Station in 1845. Now, that is on the other bank. The port is on this bank, on the Calcutta bank. Automatically, all the cargo and the men who used to come for this port, they had to cross the river. And the demand for a regular crossing became very loud. The first solution came in the form of a pontoon bridge. An illustrious engineer, Sir Bradford Leslie, who was also responsible for the development of Sir R.N. Mukherjee as an engineer, he was given the charge, and he was also responsible for the Jubilee Bridge near Bandel, Noihat. After that, he was given the charge of this pontoon bridge, and he was very fond of pontoon bridge per se. And this is a bridge which was designed and constructed by him in 1874 with a design life of 25 years, expecting that by 1909 there will be another bridge coming up. The bridge, that pontoon bridge, unfortunately had to continue till 1943. So the pontoon bridge had a life of 70 years, even though it was thought that it will be there for only 25 years. I'll just give you a glimpse of the pontoon bridge. You can see, you know, the main part of the bridge is on pontoons. There were, of course, some spans for the river crafts to pass. And on the right side picture, I don't think you can locate that, there's a gap. There's a gap, a portion of the bridge has been taken out on the downstream, and all the river crafts, large river crafts, had to pass through that 200 feet gap. Right in front, you cannot see in this picture, but right in front, that you know, even today it is there, that pumping station, Mollik Ghat pumping station is there. And whenever this portion will be taken off, there will be vehicles standing on both sides, long queues would form, and after about 2 hours they will close it back, and then again vehicles will start. So demand for permanent land crossing grew. It was understood that it is not possible to have a interim crossing. It affects both the road vehicles and the river crafts. Both are affected, and the answer came quite late in 1943 as the new Howrah Bridge. Incidentally, the pontoon bridge was known as the Howrah Bridge. So when this new bridge was constructed, the act was passed as New Howrah Bridge Act, and this was known as the New Howrah Bridge. Now this was again an outstanding structure in those days, with a span of 1500 feet or 450 meters. It was unusually long for those days, and therefore a very considerable time took in formulating that bridge arrangement and the design, and it was a bridge which required 26,500 tons of steel. Very proudly, Tata's supplied 23,000 tons out of this as a matter of national pride. And this was the first use of high tensile steel. The other steel is known as mild steel because it had a value of 250. Now this was 350. And this is the first bridge in the world which has used high tensile steel. The fabrication erection were done by a local company, BBJ, though all British owned. Braithwaite's, Barnes and Jessops, all three are British owned fabricators, the topmost fabricators of the country, fierce competitors. But when this bridge proposal came, they did not want to let this go without their participation. That's why they formed a consortium, they formed a company with the name of BBJ, Braithwaite, Barnes and Jessops, and they fabricated and was also given the charge of erection. Even though the original contractor remained Cleveland Bridge from England, but the entire thing as a part of contract had to be subcontracted to BBJ. So with a 6-lane carriageway and a tram track, Calcutta got a new bridge which is 100 feet wide deck, and the city fathers thought that their transport problem is solved for a very, very long time. Next. Well, this is Howrah Bridge, you all know. I find the other picture is not coming, and I think something. I had a picture showing the crowding. Within 10 years of its construction, the bridge became overcrowded. That, of course, is another story. Next. The new bridge was completed in February 1943. It was in fact completed in 1942, but the political climate was hostile. British had not the courage to inaugurate this bridge in 42 because of the movements going on, and this was delayed and inaugurated in 1943 with a single tram crossing the bridge at midnight. That is how the inauguration was done. But then came partition, then came our independence, much long independence, but followed with bloodshed, migration, which unfortunately is still today continuing. We still have people coming from the other part, which became East Pakistan and then became Bangladesh. The density of the bridge almost doubled, all of a sudden. And by 1960, it was difficult to cross that bridge without, giving a lot of time. When we were in BE College, it was part of our regular travel, and it used to take some time to cross. The then Chief Minister, the only visionary Chief Minister we had, Dr. Bidhan Chandra Rai, he foresaw the problem, and he asked CMPO of Ford Foundation, which was working with Ford Foundation money, to look for an alternative crossing. Now, Ford Foundation, CMPO contacted their transport consultant, Wilbur Smith and Associate of USA, who immediately opined that a bridge is necessary, and they entrusted the Lendl Palmer and Tritter, RPT, who were permanent consultants of Calcutta Port Trust and who had also been the designers of the Rabindra Setu, or the so-called New Howrah Bridge. So they were entrusted to make a report after site inspection, soil investigation and traffic study. RPT submitted its report in 1962, and they immediately confirmed the urgent need of making this bridge, and they wanted a 6-lane carriageway bridge, another 6-lane carriageway bridge with capacity of 85,000 vehicles per day. And the present Vidyasagar Setu had exceeded that expectation also. The number of vehicles passing is now touching 100,000. They made a detailed study and they submitted their report. The first question which came is where to locate the bridge. Their suggestion was, or rather finding was, that it can only be done on the south of Eden Gardens. Because if it is further north, then traffic cannot be dispersed. The ocean-going vessels which were still using Hooghly and using Khidirpur dock required a high-level bridge, because if the vessels pass and the bridge does not have the clearance for such vessels, it is always possible that some ship will drift and hit the bridge. All of us question the present users of the bridge, why was it necessary to make this bridge so high and waste so much money? This was the necessity because there had been an accident in Maracaibo where a ship hit a bridge and the bridge had been dislodged, and therefore it was decided that it will be a high-level bridge. Then they submitted 6 low-level schemes and 4 high-level schemes for consideration by the authorities. Authorities were, of course, the Port Trust, because the bridge is on Hooghly and Hooghly belongs to Port Trust. That is why Port Trust was the authority all the time for the bridges on Hooghly. Now, all these alternatives of RPT were different design consideration. There were self-anchored suspension bridge also, and long span box girders. But RPT did not recommend or suggest or even consider cable stayed bridge, which was new on the horizon of bridge industry. Perhaps RPT thought that Indian industry would not be able to make a cable stayed bridge successfully. So as a result, now state government at that time got serious. They initiated a hydraulic model testing of the location from CWPRS in Pune to find out whether locating the piers as they are suggesting, because they are suggesting one pier to be inside the river, and how that is going to affect the Khidirpur dock and how it is going to affect the river, the hydrology of the river, the siltation pattern, which was always in doubt. Their report was available in 65. They cleared the location of the bridge with certain changes in docking the ships in Khidirpur and also some shapes of the piers. Now, after these studies, clearance was given to the Port Trust to go ahead with tendering process. It was agreed that the tender, this being a large project, it will be in 3 parts. There are 2 approaches and the main bridge. It is the main bridge which was a very attractive proposition for the international construction industry at that time, because such an unusual long span bridge was not much in the horizon. The world was passing through a recession. The OPEC had unleashed a tremendous attack on the financial stability of the world, and India was of course in a very, very bad state. Indian economy was in a poor state, but the bridge could not wait, and tender was invited. It was a global tender with approval and with provision for foreign exchange, but it was clearly mentioned that quantum of foreign exchange will be one of the major criteria for selection of the bidder. It so happened there are only 2 bids received, not only for the main bridge but also for the approaches. There was nobody from outside, and these 2 bridges from India, one was by BBCC, which is BBJ and Gammon, and the other was EPI, which was just formed for taking Indian construction industry to the Middle East and Arab countries in a big way, and that is why all major central government agencies, they participated together for making this EPI. Now, EPI had never done a bridge, never done a project till then, but they did make a serious effort. They appointed another British consultant, Mortier and Anderson, for helping them in tendering. BBJ and Gammon, of course, had joined together, and BBJ had good relationship with Freeman Fox and Partners, who were the consultants from Mokama Bridge and also helped them for the Brahmaputra Bridge, and therefore automatic choice of BBJ. And Freeman Fox and Partners those days was #1 company from England for bridges. So the offer which came, the bid which came from BBCC, you can see on the top, it had 457 meter span, as was the tender condition. It showed 1 pier in water, and of course 2 side spans of 91 meter each, and it had a fan type. Fan type means it's like an umbrella arrangement of cables. The EPI offer was also incidentally cable stayed, but they followed a 550 meter span, almost 100 meter more, and the bridge itself was 200 meter longer, almost. It was more than 1,000 meter, more than a kilometer total bridge. But it had a hard type of arrangement for cables, where the cables are all parallel. It looks like a heart. Now both of these, as you can see, were aesthetically very attractive, and both the parties were extremely keen to land with this contract. BBJ, because it found with very little bridges in that time, with the country's economy in a poor state, I mean, this is one bridge which could make them leave. It was a live or die situation for them. For EPI, this was a passport to enter Middle East. If they can do a bridge of this size and this importance, then automatically they will have a credential which is big enough. And it was indirectly also a fight between the state and the center, which we are so accustomed to. The central government agencies were all supporting EPI, and through them EPI was trying to get support from the central ministries as well. So far as BBJ is concerned, they were trying to get support from all the chambers of commerce, even the trade unions. You see, I being a part of the tendering process, I remember I have visited Muhammad Ismail, Muhammad Ilyas, all their offices to get their support so that the Bengal, laborers from Bengal, the workers from Bengal has job in this bridge. And it was a fierce fight. There were technical issues as also there were, political and social issues. Next, please. Now, RPT was given the task for evaluating the two tenders. And after very close scrutiny, and they came to the conclusion that the BBCC tender is a better one, in the sense it has been done with riveted construction, whereas EPI, who had Tribeni structures as their component and Voestalpine of Austria as their partner, they had suggested welded construction, welded joint. Now, welding quality level was not acceptable in the country at that time. And there was tremendous difference between the members of technical committee of BBCC, and that was aided by another event which I will tell you later. But the fight came to a point where RPT's recommendation was challenged. Then it was referred to railways, that whether, because railway has more experience in steel bridges, that which design is acceptable. And railway chairman, railway board appointed a committee which gave a clear direction that at this point of time, welded bridge cannot be done, and therefore riveted design is preferable, and that is how BBCC got this contract. There was a tunnel offer. DCL was involved with that offer as a consultant, but it was an incomplete offer and there was no firm pricing, and therefore it was rejected. EPI's tender, incidentally, because of the longer length and all that, was costlier also. So that also helped. Now, can we go to the next? Now, RPT, no, sorry. Yeah, next one. Now, after the job was awarded, there were still debates going on. Because all over the world, number of long-span bridges have failed. And number of long-span bridges had failed in Europe, in Australia, in America. And these failures unfortunately got associated with cable-stayed bridge, because some of these were having a cable-stayed span also. The failures actually happened with box girder construction. Instead of an eye girder, instead of a plate girder, at that time box girder, which is a box, had come in, and everybody was trying to make the plate, the weight less, and make the plate thinner. And these are all welded box girder. Now, in this process of economy, to achieve greater economy, the Lakshman Rekha was crossed, the design aspect was ignored, and one by one box girders failed. And one of the very major disasters happened in Australia, in Melbourne. The bridge across River Yarra, still known as one of the biggest failures in bridge industry, and a lot of people lost their life because the bridge fell on the canteen when people were having their lunch. And it so happened, Freeman Fox and Partners was the designer of this bridge. So the opposition was very vigorous that how can we leave this bridge of ours in the hand of people whose bridge has failed. So after a lot of debate, a solution was found that let us have another consultant, another renowned consultant who will check the design before it is accepted. And the choice fell on Leonard and Andra from Germany. Now, Lua, Freeman Fox, it so happened, accepted. They were already in the defensive because of the failure of the Yarra Bridge. And am I taking too much time? Shall I? I find Dada leaving, so that's why I was wondering. Now, so Leonardo and Andra, they started checking the design submitted by Freeman Fox. They made some changes. I will show you the changes on the drawing. But they wanted the side spans. They had two spans in the side. 180 meter divided into 2 into 91 meter. They wanted single span. Then the cable which was formed with parallel strands, they thought that it is better to have parallel cable. Incidentally, you will be interested to know that today the same consultant is working for the restoration or rehabilitation of the Vidyasagar Setu, inspection and rehabilitation, and now they are suggesting that we should go back to parallel strand rather than parallel cable. Engineering design basis changes with time. Then they wanted the fan type to be changed to hybrid, mixed harp and fan. And they also suggested that the foundations, Freeman Fox had designed the foundation in the pattern of the Howrah Bridge. In Howrah Bridge, the foundation has got 21 chambers, 3 into 7, and 84 feet by, I think, 7 into 30, about 200 feet, 180 feet. One foundation with 21 boxes, and that is how the caisson is. Now, Freeman Fox suggested a rectangular caisson of similar nature, not so big, but they suggested, Lua suggested that this should be circular caissons, of course with wall inside, and BBCC component, Gammon also found this attractive, and therefore this was accepted. So all these changes were accepted. Next one, please. You see, this was the tendered project on the top, and this is the revised bridge which we have today. You can see that the side spans are larger, the cable arrangement is different, the top of the tower configuration is different. Of course, the other things you cannot see in the drawing, but everybody accepted. Freeman Fox accepted, BBCC accepted, HRBC accepted, and it was thought that we have a clearance for the bridge to start. But no, Lua now came forward with another suggestion. They were insistent that the RC deck, the concrete deck, it should be made composite with the steelwork in the deck, such that, well, Freeman Fox's design also showed composite deck, but that was the cross girder and stinger was composite for only the deck. But Lua wanted that the entire deck will be composite as one progresses with erection, so that every section of the deck, when it cast, it will set for 28 days, and after that the next section will be cast, so that the dead load also is resisted by the previous section. Now this was something which was just not acceptable to Freeman Fox. Freeman Fox's argument was that this is, you are depending on the behavior of the deck after 28 days, when the concrete is still not matured. And the values, the characteristics of the concrete deck, like modular ratio or even the strength, it will not be same because it keeps on changing with the weather, with the environment, and therefore one cannot depend on this value to be sure, and one would make mistake in the stressing of the cables. And this argument went on for more than 6 years. The disagreement was insoluble, and it came to a completely unacceptable point, and very sadly, an engineering decision had to be taken by political maneuvering. Decision was taken by the Ministry of Transport in central government and the Chief Minister of Bengal, that they will reverse the role of the consultants. Lua will become the design consultant for the contractor, and Freeman Fox will become the checking consultant reported to BBCC. It was a last-ditch, sort of last-minute decision, and fortunately, the consultants and the contractors, everybody was tired and was worried that the bridge will never come, agreed, all the parties agreed, and this is an arrangement which was accepted. Without, of course, thinking all the implications. The tender was a lump sum tender, EPC, engineering, procurement and construct. BBJ had given a firm price, depending on their design. And if you change the design, automatically the price becomes undependable. It is no more acceptable as per the contract. Now, even with that, it was agreed, and this is where this sort of excellent attitude of West Bengal government, or rather the HRPC came in. They wanted the bridge to continue, and that's why they took a very, very sort of long-term decision that we should try to adjust, and the pricing would be done parallelly. A separate section was created so that the work can go on, and the contractors can get the prices by negotiation after explaining why the changes have come and how the quantification is accepted. Now, the final arrangement of the bridge is what you see here. Now, here I will seek the indulgence of the listeners. That you see, as you can see, on the left hand side is Calcutta. The end pier, that is called Pier 1. And the second pier, the tower, which is on the bank of the river, which is called Pier 2. And then there is the Pier 3, which is inside water. And of course, Pier 4 is on the Howrah bank. Now, I will keep on telling P1, P2, P3, P4. Please excuse, I will not identify the location. So kindly remember, the Pier P1 is near Prinsep Ghat and Pier P4 is near Navan. These are the locations. Now, Pier P1 is on Calcutta side, is on land, and therefore it can be easily sunk by normal process. Pier P2 is also on the river bank, partly on land. But it is Pier P3 which is in water, and the water level keeps on varying by 6 meters with the tide, and it varies every day, 4 times in a day, and through months, and you have got the nip tide and the high tide. And Pier 4 again was also on the Howrah bank, and therefore comparatively easy to handle. Next. As far as the bridge is concerned, in the vertical profile, what you see in the elevation, you see the mandatory clearance from the high flood level was 32 meters, more than 100 feet. Enough to ensure unhindered passage of these ocean-going vessels, which had of course stopped, or not stopped, but reduced in number, because ships were becoming bigger. Up to 16,000 ton displacement ships could be handled in Hooghly, and ships were becoming bigger. They were gradually become 100,000 ton or even 200,000 ton. The gradient on the deck was 4%. Normally we give 1 in 30, but here 1 in 25 was allowed, and that automatically stopped all sort of movement of non-motorized vehicles. No rickshaws, no sort of hand carts or things like that. The Howrah Bridge was designed considering bullock cart, but this was designed considering the elimination of non-motorized vehicle. The height of the tower is about 100 meters from the road deck. The cables are rigidly held on the deck girders. They are connected to the deck girders, and on the tower at the top there is a special section called flower, inside which there was place for stressing the cables and for accommodating the cable. The original design of Lec5 provided for fan type, where the cable will go on top of a saddle. It will just cross that saddle, and it would not be anchored on the top. But here, on this design, it had to be anchored on the top. So it had to be anchored on the top and anchored at the bottom. The number of cables holding the deck was 152 numbers, and their cross section varied depending on the force in the cable, because the ones which are closest to the tower were taking less load, less tension, and the ones on the other side were taking more tension. At each of the 4 corners at the end, the bridge was being held. At every corner there were 4 holding down cables, vertically holding down, and that was holding the bridge in position, because the bridge with unsymmetrical loading has a chance of lifting up, and that was being held by 4 cables at each corner. So total 16 cables were there. Next. You see the special features of this bridge as far as substructure is concerned. You know, it is a tidal river, very different from a normal river, where you know, even if the levels fall, there is a calendar on that. But here, 4 times in the day, high tide comes and low tide comes. So the level keeps on varying. Then there is the tidal board. You know, all BE college students know what a tidal board is. At least the past ones knew what is the force it would bring and how much of loose material will come with the tidal board and would hit the foundations. The walls of the piers had to be designed against impact by vessels. There could be vessels gone astray and come and hit the pier. And therefore you had to design the wall for resisting that. You have to provide fenders also. This superstructure, the deck slab, as we mentioned, has been designed as a steel concrete composite unit to resist the composite force delivered by the cables from the dead load stage itself, whatever Lua had wanted. And incidentally, before the actual work started, Dr. Leonard